Okay, so properties of polynomials. Tomorrow we'll practice factoring polynomials, rational expression, rational exponents, radical expressions, and we'll take our tests. Okay, so today's just going to be a refresher, some exponent rules, working with polynomials, some operations, and then be off and running. Okay, so you do. Okay. Take a second here in your notebook to tell me if these are true or false, and if they're false, correct those to make them true. Okay, letter A, 5 to the 0. Ben, is 5 to the 0 power equal to 0? What is it equal to? It is 1. So 5 to the 0 power equals 1. Okay. Charlie, a to the 5th times a squared, does that equal a to the 7th? That is true. C, b squared cubed, does that equal b to the 5th? Dayton. Okay. What would make it true? B to the 6th. Good. Okay. We multiply when we are crossing parentheses. D, x plus y squared is equal to x squared plus y squared. Teddy, is that true? I need a yes or a no.
I think it is.
Okay, so Ben says no. Ben, what is that? What is x plus y squared? What's that? Okay. Which is x plus y times x plus y. So if we FOIL that, no. So you were right. X plus y squared is x plus y times x plus y. That brings in FOIL, so really that's x squared plus 2xy plus y squared. All right, and then the last one, x squared plus x squared, does that equal x to the 4th? Simon, what do you say? Correct. So x squared, so think of apples. If I have one apple and add another apple, I have two apples. If I have one x squared and I add another x squared, I have two x squareds. Okay, so this was just kind of a quick refresher on different properties with exponents, what we can do with those exponents when we want to combine them together. Okay, all right, so exponent rules. So we talked about this one. We will multiply whenever we go through or go when there's a parenthesis separating them. Because if I told you, if I just did something and I said 5 parentheses 4, you would multiply those together. Well, same thing with exponents. If you're crossing a parenthesis, think of multiplication. So this would be 4 to the 15th power, which would be a really, really big number. All right, 2z times 2 raised to the t power. Anybody remember what that equals? What can we do if we're multiplying with the same base, but we have different exponents? What can we do? Any guesses? Taylor, what do you think? What do you mean combine? Not z times t plus. Okay, you were close though. Good. If we are multiplying and we have the same base, so that 2 is our base, we actually add our exponents. So this would be z plus t. All right, 7b all raised to the 3rd power. Is this the same as 7 cubed b cubed? Can I do that? Yes. Okay, so this one with multiplication with a product, the 3 does apply to each piece. Okay, so 7 cubed is actually 343, so this would be 343b cubed. What about if I have a quotient, some fraction that's raised to the m power? Will that apply to the a and to the b? Is that a true thing? Matthew, what do you say? You got a 50-50 shot. Yes. Okay. So this is a to the m all over b to the m. It does apply to the top and the bottom. And then last one on here, if we have anything raised to the 0 power, so g raised to the 0 power, that's just going to be 1. So this was a quick refresher on all these exponent rules, what we can do with exponents. When we combine by adding, like we had here in the second one. I don't have this one on here, but what happens if we had 2, let's say, z minus t? What can I do if I'm subtracting in the exponent? This becomes a fraction. This becomes 2z all over 2t. And if I'd given it to you in this fraction form, 2z over 2t, you would think of, okay, same base, I can subtract my exponents. Question, Simon? No. All right, so let's do a couple practice ones here. So simplify this quotient. -2 m to the 6th all over t squared z all raised to the 5th power. Charlie, why don't you close your Chromebook, put out your notebook, and work on this one with me, please. Yep. Even 4-1, Matthew. You can head out now. So I'll put this video and notes online. Okay, so let's tackle the top piece first. Well, we know this 5 is going to apply here on this -2, so it'd be -2 to the 5th, and then m to the 30th. And then in the denominator, the 5 is going to apply to the t squared, so this would be t to the 10th, z to the 5th. All right. The only thing we could simplify if we have a number raised to a number, I want you to simplify. So what's -2 raised to the 5th power? It's -2 multiplied 5 times. Dayton, you got that mental math in your head? Or Simon? No. But -2 times -2 is what? +4 times -2 would be a -8, times -2 would be a +16, times -2 would be a -32. So -32 m to the 30th all over t to the 10th z to the 5th. All right, if you have a number raised to a number, I want you to keep going with it. M to the 30th we can't do anything with. T to the 10th, z to the 5th we can't do anything with. What about this one? -4 raised to the 0 power. What does that equal? Maddie, what do you think?
So would it just be one, or since the negative is right there without it?
One of your responses is correct. So think about, yeah, order of operations. So yes, think about this as -1 times 4 to the 0 power. So yes, -1. So you were correct. Kind of, wait, there's an extra little piece there that's kind of tripping me up. What about 7 times r times z times t, all raised to the 0 power? Anything raised to the 0 power is 1. Okay, and there was nothing, no additional operations going on with this. So that 4 raised to the 0 power, that's the one piece, but then that negative there. If it had been, if this was changed up, and they said it like this, then I would say, yes, that is just 1. So parentheses are important. All right, let's talk some terminology. So when we're working with polynomials, we talk about the terms of the polynomial. And so the terms are simply just each part separated by addition or subtraction. So addition or subtraction is the only thing that can break apart terms. So 7ABC, that's still just one term. But 7 plus B plus C, that's 3 terms. Talk about coefficients, and that's just simply the number in front of the variable. We can work with like terms. So like in that warm up, if I had x squared and another x squared, I can combine those to become 2x squareds. The degree of a term is simply the exponent, or we could think of the sum of all the exponents in the term. So we have all in one term, we have x to the 5th, y to the 2nd. The degree of that would actually be 7. And then if I ask for the degree of the entire polynomial, we would say, well, in standard form, the largest exponent. So once we put it in standard form, it should be descending exponents anyway. So the degree of a polynomial will be that leading term with that highest exponents on there. That would tell you the degree of the entire polynomial. All right, so this is just a review of terminology that you've seen before, but it's good to show it again just to make sure that we're comfortable with it. We've already been talking a lot about this term, but here's just another place where you have it. Just more times you hear it, more times you see it, better it'll sink in if it hasn't already. Polynomials we can classify by the number of terms. What's a one-term polynomial called? What'd you say, Teddy? Yep, monomial. Two terms, binomial, a bicycle, 2. Three terms is a trinomial. And then anything 4 terms and beyond, you simply classify by the number of terms. So if it was a 10 terms in your polynomial, you just called a 10-term polynomial. But the first three, monomial, binomial, trinomial, have specific names. Okay, we can also classify by degree. So a degree 7 polynomial, this is a constant. So if you think of it like 7x to the 0 power, well, that's the same thing as just 7 on its own. So x to the 0 power is just 1, so it's 7 times 1. So a constant is degree 0, but there's no variable with it anyway. Degree 1, we classify that as linear, so that'd be like 7x to the first, which we would just write as 7x. And linear comes from graphing. If I were to graph 7x, it would just be a line of slope 7. Degree 2 is a quadratic. So in algebra 2, you spend a lot of time working with quadratics. So like 7x squared is a quadratic. Degree 3 is a cubic. So 7x cubed. Degree 4 is a quartic. So do not confuse degree 4 with a quadratic. So degree 4 is a quartic. Degree 5 is called a quintic. I don't even have that one written down, but then anything after degree 5, it simply goes by the degree. So a degree 6, you would say 6th degree polynomial, and so on. All right. So let's do a little practice here. Identify by the degree and the number of terms. So again, make sure it's in standard form. So this one is in standard form. So there's no special name for this. There would just be a degree 7. And the number of terms, I have 3 terms. So this would be a trinomial. Now, a little twist they could throw at you is they put a exponent in the denominator. So 2t to the 4th minus 1 over t squared, okay? This one fails, does not apply in terms of degree, but we could call this a binomial. Okay, so degree does not apply on this one. But there are 2 terms happening. And if they give you something all combined together where there's no addition or subtraction separating anything, that's just 1 term, so that's a monomial. But then degree is the sum of these together, which would be 5. So this would just be a degree 5 polynomial, but it's still only considered 1 term, so it's a monomial. And specifically, I didn't have it on that slide, but degree 5 is called a quintic. Quintic. So quartic, quintic, degree 6 then goes into just calling it a 6-degree polynomial. Okay, adding and subtracting polynomials, we've done this, so I'll probably go through this one probably a little faster. Adding and subtracting, all we do is combine like terms. There's nothing else we need to do. We don't have to play with the exponents at all. We leave the exponents alone, but we can combine. So if I look at negative 3m cubed minus an m cubed, I would have negative 4m cubed. So do not overlook the operation. So it's negative 3m cubed minus an m cubed would be a negative 4m cubed. And then if I had this printed out, I would simply mark those off as I go along. I got negative 8m squared minus 7m squared. So that would leave me with a negative m squared. No, it wouldn't, because I'm going to subtract them. This would be a negative 15m squared. It's negative 8 minus 7 to get negative 15. And the only thing left is the constants. So 4 minus a negative would be addition, and so this would be plus 7. For adding, do the same thing. Next slide I have is if we multiply, we don't need to work this one out. We should feel comfortable. We can FOIL this. If we've done enough practice, we can FOIL the polynomial. If we have a 3-term multiplied by a 3-term, this is simply, FOIL is the distributive property. But FOIL only works when you have a binomial times a binomial. So a 3-term times a 3-term, you just take each one at a time. So 3a squared times a to the 5th, I'm sorry, a squared times a cubed would be a to the 5th. 3a squared times 2a would be a positive 6a cubed. 3a times my negative 8 would be a negative 24a squared. So first term, through all the 3 on the other one. And then I'm going to go to the next one. Negative 4a, so this would be negative 4a to the 4th, minus 8a squared, and then this would be a plus 32a. And then plus a cubed plus 2a minus 8. So I end up with a nine terms here when I've multiplied through, because it's going to be 3, then another 3, then another 3. So let's look to see what we can combine. So let's see here. 3a to the 5th, this is my largest one. I don't have to do anything with that. Let's go 4th. All I have is a minus 4a to the 4th. Let's look at cubes. So I have 6a cubed plus 1a cubed, so that'd be 7a cubed. Squareds, I have a negative 24 and a negative 8, so this would be a negative 32a squared. 32a and 2a would be a positive 34a, and then minus 8. So now I have my polynomial in standard form, simplified as far as I can go. Difference of squares. So we've seen this before. If I have 2 things that are squared and I'm subtracting them, I can break it up to be a plus b, a minus b. So if they give me two binomials and I recognize that these are simply just an opposite operation in between, I can kind of work backwards and say, okay, I know this is going to be, so we're at this step. And so I could say, okay, well, that's 3z squared minus, because it's a difference of squares, 11 squared. So on this difference of squares, they give it to me as binomials. I don't need to FOIL this out because I recognize it's the same terms, just a different sign. Use my exponent properties. This becomes 9z squared minus 121. So in Algebra 2, we did a lot of work where we started with a difference of squares, factor it out into two binomials. This one, they gave me two binomials, but that's no problem. I can work with that to write it as one single difference of squares. Okay, and the last one, won't go through expanding this, but the big thing I want you to recognize is this is 2m plus 5 times 2m plus 5. And so we could FOIL to be able to work this one out. If they give it to me as cubed, that's x plus y times x plus y times x plus y. So how I would attack this, I would pick 2 and FOIL. That will give me x squared plus 2xy plus y squared. And then I have to multiply it by x plus y. And so I'm going to take each term individually. I'm going to take x squared times x to get x cubed, x squared times y to get x squared y as one term. The middle one, 2xy times x would be 2x squared y plus 2xy squared. And my last term would be xy squared plus y cubed. And when combining like terms, they have to be identical. So x squared y is only going to match up here with these x squareds y. So I would have x cubed plus 3x squared y's plus 3xy squareds plus y cubed. Now, how far out they go, I can keep using my distributive property and keep going with it. So that was just a crash course on polynomials. That was in Algebra 2. That would have been quite a bit, several days worth of material. All right, so R3 is in Math Excel. So start working on that. And then tomorrow we'll start the next review section.